Assalamualaikum. My name is Muhammad Amar Hanafi bin Jamilai. Today, I will present about solar tracker system. The introduction is in today, every increasing population and never-ending demand for energy, we are on the verge of running out of resources. If not now, then in coming 50 years, there is a need of greener source of energy is getting higher and higher. Solar power provide the way to extract the energy from the sunlight while keeping in mind the concept of preserving the environment. With efficiency generation of energy from the sun and the proper usage of the energy generated, we expect to have a greener source of energy with higher efficiency. A solar tracker system has been designed, mounted and tested to maximize the amount of solar energy that can be obtained from the sun in order to provide an efficient solar system. This will allow the solar panel to send sunlight with this solar tracking system and change its orientation towards sunlight so that the solar panel can be powered. The objective. The aim of this project was motivated by the need of cleaner and a greener source of energy at a low cost and at the same time keeping in mind the carbon footprint of every energy source we use and consume. We leave a huge impact on our environment as we burn through all the available resources. The impact on the environment calls for our attention and a way for us to shift our mode of energy generation from totally non-renewable to a hybrid solution of some sort. These projects aim at building a solar tracking system that will be able to track the position of the sun and align itself in the desired orientation in order to maximize the power generated by the solar module by the means of facing the direct sunlight. The schematic diagram of solar tracker system from Tinkercad. In this project, when the light-dependent resistor LDR1 detect light, the motor will rotate reverse or anti-clockwise. When light-dependent resistor LDR2 detect light, the motor will rotate forward or clockwise. Here is the picture of schematic diagram. You all can see it's been used for resistor, 1 DC motor, 2 LDR and 1 power supply. The result. In this schematic diagram, the LDR1 is on, so the motor is rotate reverse. Motor rotate anti-clockwise. Motor is reverse because RPM is negative. The RPM get negative 56 RPM. Result 2 in this schematic diagram, the LDR2 is on, so the motor is rotate forward. So the motor will forward because RPM is positive. The RPMs get 160 RPM. The discussion. In this project, solar tracker system, the component that been used is for resistor 10 kilo ohm, DC motor, power supply 15 volt and 5 ampere, 2 ohm 741 and 2 light dependent resistor. The function of resistor is to slow down the motor rotation and make the speeds of the DC motor decrease. If the resistor been adjusted to higher than 10 kilo ohm, the DC motor rotation also will decrease. So, the resistor and DC motor are interconnected with each other. After the circuit is complete and the Tinkercad been run, the DC motor will not rotate. It is because the circuit cannot be operated if they have no light to detect. Next, if the LDR1 is on, the DC motor will automatically on and rotate reverse anti-clockwise. Then, if the LDR2 is on, the DC motor also automatically on, but the rotation will forward clockwise. So, to be concluded, the DC motor can detect with high precision because it rotates based on the LDR that have detect light. So, in conclusion, this project that has been built has been successfully complete on the basis of the state goal. Smart solar tracker absorb energy efficiently with the help of LDR, light dependent resistor. Light dependent resistor, it also remove The manual work of solar energy control system. The solar tracker system will automatically turn left based on the passage of sunlight, turn center and turn right. The output of the DC motor system can be reduced if the LDR, light dependent resistor, describe the solar energy that can produce and sustain the cost of excess electricity consumption. Thank you.